In this video, we are going to learn the order of the strength of hypophosphorous acid, phosphonic acid, and phosphoric acid. So, in the case of the oxo acids, where we have the same elements hydrogen, phosphorus, and oxygen present, then we use a technique, or we use the oxidation state of the central atom to indicate the strength of the acid. But in this case, we will see a different scenario. Here, the strength of the acid will not only depend on the oxidation state of the central atom, but it will depend on another factor. So if we see here, the oxidation state of phosphorus here in phosphoric acid will be so here the oxidation state of phosphorus is +5, and in phosphonic acid the oxidation state of phosphorus is +3, and in this case of hypophosphorous acid the oxidation state of this phosphorus is +1. So if we look at this point, then this acid should be the strongest acid, and this acid should be stronger than hypophosphorous acid. But in reality, we see that the hypophosphorous acid is stronger than phosphonic acid, and the phosphonic acid is stronger than the phosphoric acid. So why this happens? So here, if we represent this phosphoric acid in its bonding structure, then we can see here we have one phosphorus oxygen double bond and 3 phosphorus and hydroxyl group single bond here. So here we can see the 3 oxygen have their lone pairs on them, and here we can see there are 2 OH groups and 1 phosphorus oxygen double bond, and in this case there are 2 2 phosphorus hydrogen bond and 1 phosphorus hydroxyl bond and 1 phosphorus and oxygen double bond. So if this phosphoric acid gives 1 proton, then what we get? We get a negative charge on this oxygen, and this negative charge can be participate in a resonance structure that we show here. When the oxygen gives the electron towards this bond and this oxygen pulls the electron towards it, then we get a structure like this, and this is a resonating structure, and these 2 structures are equivalent to each other. And here we also see the electron present in this oxygen can be donated to this bond, towards this bond, and the electron, pi electron here present here, can be pulled towards this oxygen, and we get a resonating structure here. And here also we see the same case. The negative charge of oxygen, the oxygen gives its negative charge towards this bond, and the double bond and the pi electron present here are pulled towards this oxygen, and we get a resonating structure here. So basically we get the resonating structure in these three cases, and this resonating structure gives this base, I mean the conjugated base of these acids. If these conjugated base are stable, then the acid becomes stronger. So in this case we can see here this oxygen can participate in the resonance by giving its negative charge, extra negative charge, and also these oxygen have also lone pair electrons on them, which also can take part or can participate in the resonance like this, and this phenomenon is known as cross resonance. Okay, so this phenomenon is known as cross resonance. So due to this cross resonance, the probability of donating or giving this electron towards this bond is reduced, because they inhibit the probability of giving this electron towards this bond. That's why the resonance form, or the probability to form this resonance by giving this electron and pulling this pi electron towards it is reduced, and that's why the stability of the conjugate base is reduced. So here two hydroxyl group is present, so the reduction will be more, and here one hydroxyl group is present, so the reduction is a little bit less than this, and here we have no extra hydroxyl group, so the reduction will be the least. So the stability order, if we write it like this, the stability order will be like this, and the more stable the conjugated base is, the stronger will be the acid. That's why we get the strength of the acid, order of the strength of the acid like this. So hypophosphorous acid is the strongest one, and then we get the order like this: phosphonic acid, and then phosphoric acid. Thank you.